Welcome back. Today we're going to be talking about natural language processing. So first I want to start with a caveat. I'm not an expert in natural language processing, but I do a lot of work there, and I've had really good luck with some of the new techniques and doing some really fun data science with it. So I think there'll be enough here to get you started and introduce you to the area if you're new. All right, so what do we mean by natural language processing? We want to start by talking about structured and unstructured data. So in general, so far, you've probably been looking at structured data. So if you're in Data Science 10, you're looking at data that's in a table, right? It's a regular sort of column of data there, and it's got defined values and names and all that kind of stuff. Similarly, there are databases. A database is basically that same idea, but maybe on someone else's computer. So some server somewhere. These have proper types and they're organized, and it makes analysis and math much easier. Unstructured data is just a bunch of stuff on the computer. It is irregular, it's not sorted, and as a result, it's difficult to just load it up and use it, right? You don't have everything there. So an example of a sports from a sports domain, you could imagine a spreadsheet style thing. So a table with columns and rows that describes what happened in a game. So in a basketball game, like who scored how many points, when they scored them, all that in like a table. An unstructured version would be just paragraphs of text. So maybe from a newspaper, a description of what happened. So natural language processing is dealing with this particular type of data, which is just plain text, just written for humans, not for computers. That said, it's not the only type of unstructured data. So we also have logs, right? So often you'll get a series of messages from code that spit these things out, and you want to figure out what's going on with them. But they're not really formatted, again, in like a helpful way. Sometimes you get time series data that is kind of raw and not structured in a way that you're ready for. Later, we're going to talk about images in this class, and images are a special kind of unstructured data. They have a structure to them that allows you to create the image, but there's not like a part of the image that's labeled or anything like that. It's not designed for computer consumption. Videos are obviously like moving pictures, but with sound, so that's even more stuff. And then audio we'll play with in this class also. Audio data like recorded speech is a whole nother mess. But for today, we're going to deal with language. And language shows up, just natural language, in a lot of places. One of the really common ones shown here is email. But in fact, it's everywhere, right? A huge portion of the data that we deal with is text in chats and social and all this stuff. It even shows up in some places you might not expect, like these reviews on Amazon of a banana slicer. And you could want to go through and classify if these are helpful or funny or not, right? So there's a whole lot of work to be done there. In fact, Amazon is drowning right now in fake reviews, and they're trying to figure out what to do about it. And it's a really challenging problem, and natural language processing is probably part of the solution. So there's a ton of examples for this, anything from spam filtering to trying to automatically make stock trades based on newspaper reports to content recommendation, all sorts of things. So the first thing I want to say is computers are not good at understanding English or any language, right? That's not what it's designed for. And so we've made huge progress in recent years, but there are still limited things that a computer can do. So when you're first getting started, the first thing you want to do is start thinking about syntax. And you might think that this is straightforward, and it's not. So one of the first tasks you want to do is to split words into individual pieces. So you would think at first, okay, I'll just split at spaces. But then there's punctuation, there's conjunctions, there are things like em dashes and periods and quotes. There's all sorts of things around language, like names often have a space but should be considered one word. Segmenting into individual words is not as trivial as you might guess at first. A lot of work's been done on that, and so there are some packages that do a pretty good job. The next thing we might want to do is to basically unconjugate verbs. So there's a couple of ways to do this, lemmatization and stemming. They're both not perfect, but what they try to do is basically to take all of the different conjugated forms of verbs, like he drove, she was driven, right? All these different things, and just to put them all back to drive, so that you've got that uniform thing, so you can start doing math on it. Sometimes that's desirable for understanding, sometimes it's not, right? You just have to test. The last part of the syntax understanding that is okay in computer stuff right now is part of speech tagging. So like, this is a noun, this is a verb. It turns out it's not perfect, and there are a lot of places where it's ambiguous. So in the example here, the book on a table, book is a noun there, right? It's an object. And then to book a flight, book is a verb. And so figuring that out isn't just looking up words, right? Languages are imprecise and complicated, and English especially, I feel like is maybe it's just the one I know best, but it's messy. The next layer on top that we do sort of a pretty good job at is some semantic stuff. So named entity recognition can go through and pull out proper names and other sort of objects in there. So it might say, hey, this is a currency amount. This is a number. This looks like an address. Some of the more advanced ones now are linking that back to Wikipedia pages or something. So they'll say, hey, you mentioned UCSD here. Here's some information. That's a college, right? So you can get like categorization of topics. Machine translation has actually gotten pretty good lately. It's way better than it used to be. Sentiment analysis is also okay. It's people trust it more than they should, and so sometimes sort of get out past where they should be believing it and make decisions based on it that are not accurate. So there's been a bunch of discussion around the election and sentiment analysis of online posts trying to predict election outcomes, and like, I just don't think that's a good use of sentiment analysis right now. But some other things totally can be. So rough classifying of reviews into positive and negative, so that you can figure out which ones to respond to. Stuff like that, it does an okay job at. There's a lot of tasks on semantics that we haven't gotten there yet. And so there's active work. I mentioned earlier that I'm not an expert here and that other people are, but there are entire departments and I don't know how many thousands of graduate students and professors working on these problems. Natural language understanding is a huge area. So that's really about understanding intent. You can think of it as making Siri stink less, or Alexa, or whatever your assistant is, right? Trying to figure out what you're actually asking for. Question answering has gotten better in some limited domains. You might see Google having more and more boxes that have some automated question answering in them. But in general, the things around like chatbots trying to help you, if it doesn't have pre-canned stuff, if it just has a bunch of help files and previous logs, it's not great yet. Relationship extraction is another task we're getting okay at, and that is really like, imagine scanning through a bunch of newspapers and trying to identify the relationships between people. So you might see Michelle Obama and Barack Obama, and then understand that they're husband and wife, and then be able to scan through and figure out who their kids are and their employees, and sort of make relationships, in that case, between people. There are other kinds also. Topic segmentation and recognition is a challenge, and word sense disambiguation is a real challenge. So we talked about the two meanings of book, but sometimes you'll have two nouns. So if you say there's a jaguar in the forest, you're probably picturing a cat, right? And if you say there's a jaguar on the freeway, you're probably picturing a car. And so that disambiguation of concepts is still very difficult, very cutting edge. So in Python, in the stuff we're working with, a good place to start is NLTK, the Natural Language Toolkit. So you can get started very quickly with this, and it's very customizable. So you just import NLTK. We have a sentence that's just a string. If you haven't seen it before, the triple quotes are just an ability to have a string that goes over multiple lines. And what we do here is we tokenize a word, and you can see it splits it out into individual words. You'll notice it splits the period out into its own, and nt out of didn't actually is its own. So it's doing something a little more clever. It also kept a clock together. So like it's got some stuff in there, right? And then here we're doing the part of speech tagging, and so it's going through and tagging the parts of speech. I never remember all that stuff, so anyway, it does that. And here we can start going through and looking at named entities, so it can recognize all sorts of things there. So in particular, towards the middle there, it can see that Arthur is a person, right? So cool. You can even do things like sentence diagrams. I don't know if you had to do this when you were in middle school or junior high or whatever, but I do not remember how they work, but this is a thing that computers can do, and they're okay at now. So there's a bunch of other stuff. In the exercise today, we're going to play with sentiment analysis and do some work there. And we'll do an intro to NLTK with some overviews. We're actually going to pull some UCSD tweets and try to understand if the individual tweets have positive or negative statements about UCSD, and then you can look at the actual language and see if you agree. All right, last bit here. In this class, we're going to do just a real brief intro to natural language processing, but I want to mention the existence of other tools than NLTK, which is what we're using. So one thing is there are a lot of pre-canned commercial solutions. So all the big cloud folks have stuff. In particular, they all offer translation services. Strong recommendation to not try to do that yourself. The resources required to do a good job at translation are enormous, and you are not going to do better than they are. It's almost always better to just pay them, or even to pay a human to do translation work. They also have a bunch of other services. Some of them, like named entity recognition, may be about the same as the open source one. They just wrap it up so you don't have to host it or whatever. Maybe they're better. I don't know. So commercial solutions exist. For Python, there are a few other things. Spacey is one I like. Spacey is pretty similar to NLTK for some tasks. It doesn't do nearly as much stuff, so the options are a lot more limited, but no joke, it's about 500 times faster for the tasks I do. So when you're working at scale, trying to do millions of documents, that can be the difference between a couple $100 and tens of thousands of dollars in compute time, right? So it can really be worth it. Also, if you're trying to do stuff in real time, something that's faster can be great. So NLTK I really like for research tasks, but most of my production stuff uses Spatie. And then there's been a huge revolution in deep learning in the last couple of years. I'm not going to get into all the cool stuff you can do with that, but I will say that I have been totally digging the Hugging Face transformers lately. It's kind of a goofy name, but it's by far the easiest way to get into deep learning natural language processing. I was not super familiar with all that stuff, and within a day I was able to do a classification task. Basically, I tried to automatically label documents as internal only or approved for external release, like public-facing documents, on actual work stuff. We had a bunch of labeled documents. We had some we wanted to label. I was able to train it on GPUs and do all the rest, and it was really quick and easy. So big shout out to the Hugging Face team for making that more accessible. In addition to supervised classification, they do a bunch of other stuff around question answering and summarization, and people are extending this. They've made a really nice platform so you can add additional features to transformers to Hugging Face and make them accessible. So cool place to check out. So that's all I've got on natural language processing today. Like I mentioned, it's a huge field with a lot of interest and a lot of diverse applications, and we're going to get into it in class, and I hope you enjoy it. All right, thanks.